Good evening, everybody. Welcome to Chem 1105 with your host, me, Dr. White. Hi, everybody. Let me get a little closer here. And good evening. Today we'll be doing, or tonight, I'll be doing the review for test number 1, which I'll be giving this Thursday. Now, don't forget, this Thursday I'll be sending out an email about 8 a.m. or maybe earlier with the password for the password protected PDF file that you will download from the assignment area Blackboard. You can't see it now, but you will Thursday morning. And you'll have until Friday, I think it's 8 p.m., to take test number 1 and upload it as a single PDF file. Yes, single PDF file to the assignment area in Blackboard. And then I'll grade it by Sunday, 1 p.m. I will send back, email each of you an individual email with the points for each answer on test number 1. Also, by that time or sooner in Blackboard, I'll put your test score. And then the following Monday, 8 p.m., and I'll send this out in an email, I will go through the answers online like this. Hold on, I'll get to your question in a second. Hopefully I'm pronouncing your name right, Mashid, Sheed. I hope, well, you correct me. But anyways, I'll get to that in a second. And that's the upcoming thing. But before I do that, there are two things I want to do. First of all, let me answer the question. No, you don't have to print it out. What you can do is, hold on one second. That one. What you can do is, if you don't have a printer like I have right there, you can just write it on a piece of paper and then use a scanner, or if you don't, use your cell phone, and Cam Scammer works real good. Students this semester have been using it. My students have been using that for a couple of years now. Use the free version and upload it. By the way, if we were face to face, you'd have 55 minutes to take tests. Most students are done 35, 40 minutes, like almost all of them. But since you're home and maybe your kids or whatever interrupt, take up to 3 hours, but get it uploaded by on time. So first of all, does that answer your question? You're welcome. All right. The other thing I wanted to show you, which I was surprised some students didn't know, but then again, maybe I didn't clearly show it. Let me log into Blackboard. And I'll go into the section net 8. 9 is identical to 8 except different students. And let me go to student view. All right. One of the things to help you do good on test number 1, and after I say this, I'll start my review, is if you notice on the left where it says course information. If you click on that, you'll see lectures, and all the lecture slides I use in my videos are here. And I'll talk about something else in a second that's here. But here we have recommended problem sets and recommended problem set answers. And if you notice, I have for chapter 1, appendix A2 and A4, chapter 2 and chapter 3, and also the rest of the semester. But those are the ones you should do for test number 1. If you want to do good on test number 1, you should try the practice problems, and you should be able to get them right. You can find the answers. Again, course information, which you click on the left, and here it has recommended problem set answers. Remember the first video I talked about how to ride a bike, if you didn't know, or how to do well in my class, if you didn't know how to ride a bike, and I gave you the Blu-ray and so on, and showed practice helps you learn how to do something. This class is no different. All right, let's get started. One thing, a caveat, I'll try and cover everything on the test that are things you should know for the test. But once in a while, I might forget a little something. If I've talked about it in my videos, it's fair game on the test, but I don't think I'll forget anything. All right, the file you see on your screen right now, test number 1 review, is located in the lecture section of course information in Blackboard. And it's cleverly named Chem 1105 test number 1 review. So let's go through it. And these are all things you should know. Hint. All right, first of all, I started out the semester with what are the 4 branches of chemistry, and you should know at least one of them: organic, physical, analytical, and organic. By the way, organic's the best, but I'm an organic chemist. All right, next I started talking about matter. What is matter? Anything that has mass and occupies space. And then I put in now, so you can start learning it, the chemical symbols. And there are only 37. Now, for every test in the assignment area Blackboard, besides the test PDF file, you'll find this PDF file. And this is a periodic table you should use. You should not go on the internet. I'll know if you do. There's certain things in this table that will tell me based on your answers. So please use this. And you should know H is hydrogen. So if I ask on a test, give the chemical symbol for hydrogen, you should know it's H. If I ask what element has the chemical symbol C, you should know carbon. Now, you don't have to learn all the ones on this table. This one has 109. No, just the 39 that's in a list in chapter 1, the lecture, and it's in the video. All right, next, I talked about the 3 states of matter you should know. There's solid, liquid, gas. If we were face-to-face right now, I'd say, class, what are the 3 states of matter? I make you real loud say solid, liquid, gas. You should also know a solid has definite shape, definite volume. Again, you should know a solid has definite shape, definite volume. You should also know a liquid has indefinite shape, but definite volume. And finally, a gas has both indefinite shape, indefinite volume. So if I have something in a black box, I tell you it has indefinite shape but definite volume. I ask what state of matter is. Well, indefinite shape and definite volume, it's a liquid. I talked about different types of matter, pure substances, which can be either the elements or compounds, and mixtures. And mixtures are when you mix 2 chemicals together and they don't react. Each one retains its identity. You should know there are 2 types of mixtures: homogeneous and heterogeneous. Homogeneous, it's the same throughout. Heterogeneous, it's not. It's like 2 separate layers. An example of heterogeneous would be oil, vinaigrette, salad dressing. Because if after you shake the bottle up and you put it down, it separates into 2 layers. So it's heterogeneous. Now, homogeneous, if I were to take my bottle of water, put some salt in there, shake it up in a little while, it will be the same throughout. Same thing if I put sugar in there. Now, you usually don't think of it, but the air you're breathing is a mixture of different elements or compounds, not elements, compounds, oxygen mainly and nitrogen. And if I'm here, I go way over, you can't see it, outside my office, another part of my house, it's going to be the same mixture. It's homogeneous. All right. Talked about properties of matter, physical property, chemical property. Physical property tells you something about the element or the compound. Chemical property tells you how it might react. A physical property would be water melts at 0 degrees C. And that's a physical property. A chemical property, gasoline is flammable. By the way, did you figure out yet Dr. White's a closet pyromaniac when I was little? I sort of outgrew it, but it's still hidden back here. But anyways, a chemical property gives you the indication how something will change. Flora, which file don't you have? Oh, I saw a real human being.
Dr. White.
Test number 1 review.
Yes, I don't have this one on a Blackboard.
Let's find out.
Yeah, I don't either.
What section are you in?
Let me go on Blackboard.
9 or 8? Flora, what section are you in? Net 9?
Just give me, I'm
9?
sorry, just give me 1 second. Let me go on.
I'll give you
I'm in 9.
2 seconds. But while you're doing that,
Okay, course information.
all right. Do you see on your screen?
Yes.
Can you see where it says Chem 1105 Test 1 Review? I'll repost it, but I didn't, for some reason, I didn't have it as a PDF file. After today's review, I'll repost it, okay?
Okay, thank you. And
Welcome, and
you're
thank
going
you
to
for
post it on,
What?
and then you're gonna post it on the lectures?
They're all here. If you look at right here, chapter 1, that's the lecture file or slides I use in my videos, okay? And this is in
Yeah.
course information, lecture folder, okay?
Okay, thank you.
And like I say, all questions are good questions. Writing a note to myself, new. All right. Let's continue. Let's see. I have the handwritten. I apologize. I forgot. I had those when students could read cursive. Both 9 and Jim, thank you for letting me know. That will be, I'll post the typed version sometime later tonight after I'm done today with this, okay? If not, tomorrow morning, send me a real nasty email. No, I've got a note right here. So I'll do it. All right, let's get back to our review. All right, next we have changes in matter. There's 2 types. Physical change, when something changes from one state to another, but still retains its chemical identity, and a chemical change when it changes its chemical identity. A physical change is when water freezes. It goes from a liquid to a solid. A chemical change is when you eat food in your stomach. Yeah, that's chemistry. And I'll talk a little about it later on the end of the semester. If you take me at Chem 12, my organic chemistry, you learn a lot about that. Your food undergoes a chemical change. It's broken down. Say, if you eat something with carbohydrates, it's broken down to glucose, a different molecule. And you should know examples of physical and chemical change. Now, at this point in the chapter, I discuss temperature. There are 3 scales we use in chemistry, and a couple of them in our daily life. F is Fahrenheit, C is centigrade or Celsius, and K is Kelvin. And the first formula is how you convert from degrees C to degrees F. 1.8 times degrees C plus 32. When you use this formula, you do the multiplication first and then the addition. That's important. You'll get the wrong answer. Do the multiplication, then the addition. 1.8 and 32 are exact numbers. We'll talk a little more about that later. For degrees C, if you have degrees F and you want to convert to degrees C, degrees F minus 32 divided by 1.8. Now here, you do what's in the bracket first, the subtraction, then the division. Students make the mistake to divide degree F by 1.8 and 32 by 1.8 and subtract. Wrong answer. Do the subtraction first, then the division. And finally, Kelvin is equal to degrees C plus 273. Now, as I've said in the video, good news. I have changed my philosophy a couple years ago. Where do I test your memory and your ability to do chemistry, or just your ability to do chemistry, not much your memory? And the answer is, I just test your ability. So at the last page of test number 1, I'll do similar for test 2, 3, 4, and the final. I have some important information that you don't have to memorize. A number of years ago, you'd have to memorize these formulas. And later on, this information you would have to memorize. You don't. It'll be given to you. All right. And hopefully you've done the practice problems for temperature. Now, next thing I talked about is scientific notation. And scientific notation is where you take a very large number or small number, real tiny small, and it's some number times 10 to the power n. Remember, Q is never less than 1 or 10 or greater. If it is, you've done it wrong. And you should know how to convert to scientific notation. Now, I'm going to do an example or two right now, but remember, if the number is greater than 10, n is positive. If it's less than 1, n is negative. So if I were to ask you, write the following number in scientific notation, if I were to ask you to write the number in scientific notation, what do? Well, you look where, if there were a decimal point, which is right here, there isn't, but if there were, you move that decimal point, or if there were, to the right of the first non-zero number. 1, 2, 3, 4, 5. If the number is 10 or greater, you drop the zeros at the end. and the decimal point is to the right of the first non-zero number. Now, how many times did I move it? 1, 2, 3, 4, 5. So this would be 2.35 times 10 to the 5th. Now, if the number is less than 0, guess what? You still move the decimal point to the right of the first non-zero number. 1, 2, 3, 4. Now, if the number is less than 1, zeros at the end are not dropped. Like here, these were dropped. So this would be 2.20. And we moved it 1, 2, 3, 4 times. Now, when the number is less than 1, n is negative. Well, we moved it 4 times, but it's -4. So that would be 2.20 times 10 to the -4. Remember, when it's greater than 10, the zeros at the end are dropped. When it's less than 1, zeros at the end are not dropped. Now, on test number 1, I will not ask you, here's the scientific notation, write it as a decimal, because in real life, you don't do that. And I do what I do, teach how you would encounter that in real life. Now, the next thing I talked about were significant figures. And this is an important skill that you will need not only for test 1, but 2, 3, 4, and the final. And you should know how to determine in a number how many significant figures that number has. And all non-zero numbers are significant. Zeros may or may not be significant. That wasn't too helpful. But leading zeros at the beginning of a number are never significant. Confined numbers, those between non-zero numbers, are significant. And trailing zeros at the end of a number are significant if a decimal is present in the number. Trailing zeros, those at the end of the number, are not significant if the number lacks an explicitly, and that's the important part here, explicitly shown decimal point. So if I were to ask how many significant figures are in the following numbers, this one, you know, I'm going to share the fun. I'm going to give you about 15 seconds for you to figure out how many significant figures are in that number. Go. I've got a clock up here. I can see the second hands. All right, maybe it was less than 15 seconds. We look at this number, all non-zero numbers are significant. So 1, 2, 3, 4, 5. So this would have 5 significant figures. Ooh, let's do another one. And the question would be, how many significant figures does this number have? And I'll do it. All non-zero numbers are significant. Zeros at the end with no decimal are not. So this would have 1, 2. This would have 2 significant figures. All right. And if we look at this number, 345.000, again, you should know how many significant figures does that have? Well, all non-zero numbers are significant. 1, 2, 3. Oh, look, we have a real decimal point, an explicit decimal point. So zeros at the end are significant too. So this would be 1, 2, 3, 4, 5, 6, 6 significant figures. Now, I combine two things here. Question is, how many significant figures? And this number has a decimal point. Now, lead zeros are never significant. Non-zero numbers are, and a zero at the end where number has a decimal point is, so this would be 3. And that's the skill you should have. And I apologize, I don't always look at oh, I see that people are doing numbers and looks like everybody's getting things right. Good, yay. All right. Now, once you have significant figures in a number, you should know how to round it off. And I'm going to be doing this for where there's a decimal point. If the first digit to be rounded off is 4 or less, simply drop it and all the following digits afterward. If the first digit to be deleted is 5 or greater, then that digit and all that's followed are dropped, and the last retaining digit is increased by 1. Well, let's look at a couple examples. And this is a skill you'll need the whole semester, especially on tests 1, 2, 3, 4, and the final. Now here, to save time, I'm abbreviating on tests. It would not be abbreviated. Round off to 4 significant figures. And if I were to ask you round this number off to 4 significant figures, you start the first on the all the way to the left.
He's explaining how to do math for the test.
What?
You need to pay attention, write some notes. Go get a paper.
It's being recorded. It's going to be on YouTube.
I'm having a hard time hearing you. It's my problem, not yours. Can you type it out in the chat? Maybe that would help. But this is 334.67355. How do you round it off to 4 significant figures? Keep the 3, keep the 4, keep the 6, keep the 7. That's my 4 significant figures. The next number I use to round off, that's 4 or less. So I drop everything. And the correct answer here, 34.67. And here's another one. Why don't you try one? Round this off to 4 significant figures. Sometimes you have to do 2, 3, or more, but let's do 4. I see people are already answering, so I'll give you another 10 seconds, and then it'll be my turn to have some fun. All right, we want to round it off. In this case, the problem is to 4 significant figures, and therefore 1, 2, 3, 4. The number used to round off is this one, the 5th number, significant figure. Is that 4 or less or 5 or greater? And hopefully I'll pick 5 or greater. So I'm going to drop this, everything afterward, and increase this by 1. And that's how you do it. Now, when you're doing mathematical calculations, which we will do in this class, there are certain operational rules to determine how many significant figures. If you use your calculator, it's going to give you a whole line of numbers here sometimes, and that's not the right answer. For multiplication and division, you should know you get the smallest, the number that has in your multiplication or division, the smallest number of significant figures is how many significant figures your answer should be. When you have multiplication division, the number you get should have the same number of significant figures as the number with the smallest significant figures that you multiply and divide by. You'll have to round off. Addition, you get the same number of significant figures to the right of the decimal. Now, since you're here, can you keep a secret? I will not put any addition rounding off on test 1. Test 2, yes, not test 1, because I really haven't covered it that thoroughly in the videos, but for test 2, I will. So for test 1, remember, it's a secret. You only have to know the multiplication division rounding off rules, but for test 2, you have to. Thank you, Robbie. All right, let's do a quick one. And if I were to ask you, what's the answer to this problem? First of all, you have to know how to use your calculator. If you look in the video, one of the 4 videos for Appendix A2 and A4, I teach you how to use this. Don't forget to do scientific notation. It's blue key, then double E right here. And don't forget, I don't have it here. It's a minus number up here. You use the minus on the keypad right here, not this minus to get that. But let's do this one. 3.14 blue double E6 times 8.11 blue double E 23. Hit enter, and my calculator gives me this number. And if you wrote this number down as an answer, I take off a point because it's the wrong significant figures. So what do? You look at the first number here, and it has 3 significant figures. Non-zero numbers are significant. And for this problem, I made it easy. This one also has 3 significant figures. And which one of these is the lowest number? They're both the lowest 3. So you have to round this off. Three significant figures. And how do you do that? Keep the 2, keep the 7, keep the 6. Use the 5 to round off. Is that 4 or less or 5 or higher? And it's Ashley asked me how to do a calculator. As soon as I finish that, I'll do it right now. It's 5 or greater, so I'll drop this and this and increase this by 1. Remember, this is how I write a 7. You never change the exponent. And this would be the correct answer using significant figures. All right, here's your calculator. And most of these are the same, but this one you should buy. It's inexpensive and it never failed me. I've had this for at least 10 years. But anyways, and it's in the syllabus, the name, Texas Instruments. All right, to do a scientific notation, put in the first number like here, 8.99, 8.99. Now say it was times 10 to the fifth. I'm going to do, you see that? Blue, the second key, blue key, and then right here above this button, can you see the double E? When I press that on the screen, there's an E. And I said times 10 to the fifth, I'll press 5. Now, if I want to multiply this, use these right here, X, and you'll see a little star. Trying to get the reflection. And now say I want to multiply it times 1.11 times 10 to the minus 5. So I'll put in here 1.11. Now I want times 10 to the minus 5. So I'm going to do blue key, second key, double E. You see the, now I want minus. Use this, not this. Have you noticed I'll never be a hand model on TV? But anyways, I forgot to do my nails. That humor night, minus, see it's there, and I'll hit 5, and then equal. So I have that. And now this gives me 1.096668. And then I'm trying to get the reflection here out of it. Right at the end, there's a little X, tiny, then it says a little 10, then it says 01. So that'd be 10 to the 1. Let's see, who asked that? I think it was Ashley. Did that help you?
Completely different number.
Okay. If not, stick after the review and we can go through it again.
Okay, sounds good. Thank you.
You're welcome. All right. Now, next I talked about the periodic table. And you should know the group names in the periodic table. Also the name of the 39 elements, like Cu is copper, one of my favorite. You can always send some to Dr. White if you want. Au is gold. And another expensive metal, Pt platinum, Pd palladium, Ni nickel, Fe iron. You should know those 39. And these are the ones. Now, the columns in the periodic table are called families or groups. And you should know, except for hydrogen, in the first column underneath the red one, those are called the alkali metals. Lithium, sodium, potassium are the only ones I asked you to learn. I know the other ones, but those. Second column, under the number 2, you should know those are the alkaline earth metals. And those are magnesium and calcium. Then go all the way over to column 7, or not, where it says 7 in red. Fluorine, chlorine, bromine, iodine, those are the halogens. How many have heard of halogen lights? Like you see the street lights. Some are starting to be LED. I don't like the LED street lights. But anyways, those are the halogens. And finally, the last column all the way to the right, my right, and hopefully yours too, under the number 8 are the noble gases. They used to be called inert gases, but somebody found out, I think it was about mid-1990s, 95 or 96, chemists found a way to react it, won the Nobel Prize for that, and deserved it. And they no longer call them inert because they could react now. So they are given the names, the noble gases, such as neon, argon, which I've worked with, Kr krypton, which in our world is not a green solid that kills Superman, but it's a colorless colorless gas at room temperature. Again, first column, alkali metals, not hydrogen though. Second column, alkaline earth metals. Seventh column, halogens. Eighth column, the noble gases. I almost said the old name. I still do once in a while. All right, now we got some juicy stuff. You should know what is an atom. That's the smallest particle of an element. And if you want to, that has all the properties of an element. You should really know what are the 3 subatomic particles, the 3 particles that make up all atoms. And they are the electron, proton, neutron. If we were in class, I'd say, class, everybody together with me. They are electron. And if you didn't yell it out, I'd say, let's do it again. Proton, neutron. And you should also know electron has a negative charge, proton a positive charge, and a neutron has no charge. Again, electron negative charge, proton positive charge, neutron no charge. Now, where are all these pieces? Well, you should know the center of an atom, called the nucleus of the atom, contains only protons and neutrons. Again, the nucleus of the atom, you should know, which is the center of the atom, right in the very center, is where the protons and neutrons. And you should know, which I talked about in the video, that Rutherford's gold foil experiment, watch out, I'm using a really fancy word now, elucidated the nucleus of the atom. In other words, figured out that the nucleus is very dense and contains protons and neutrons. And that's what part of the atom Rutherford's gold foil elucidated. Now, when we talk about the elements, there's an important number called the atomic number. First of all, you should know that well, if you want to do good on tests, if you don't have to know it, but I think you all do. I hope you do. The atomic number is equal to number of protons by definition in an element. All atoms have a net 0 charge. Since a proton is a +1 charge each one, an electron is a -1 for those all to be neutral, the atomic number gives you also the number of electrons in an element. Again, atomic number gives you the number of protons in an element, and it gives you the number of electrons in an element. And if we go to our friendly neighborhood periodic table, you can see Dr. White's watched Spider-Man. Anyways, the movie. If we look in the upper right-hand corner, that number, like Na, where you see 11, that's the atomic number. Na, sodium, how many electrons does it have? 11. How many protons does it have? 11. If we go over to another important element, nitrogen, right here, N. You should know how many electrons and protons does nitrogen have. How do you do that? Look at the atomic number, the number in the upper right-hand corner, 7. And nitrogen has 7 electrons, 7 protons. Oh, I'm going to give you one try, and then I'll tell you. How many electrons and protons does iodine have? Your turn. time's up. And here, iodine chemical symbol, which you should know, I. The atomic number gives you how many protons and electrons, and that's 53. Electrons, 53 protons in an atom of iodine. Isn't this chemistry hard? Not really. All right, next I talked about where are the electrons? Good question. Well, they're in the electron crowd around the nucleus. And the electrons are in the shells, and shells are made up of subshells. Now, the electron shells have very difficult numbers, shell 1, 2, 3, 4, and so on. And shell 1 only has one subshell. Shell 2 has two subshells, 3, 3, 4, 4. And you should know shell 1 is the lowest energy. Shell. And on this table, 4 is the highest energy. Shell. Now, the subshells are given letters, S, P, D, and F, and I talked about what that stands for, but you don't have to know. But you do have to know, actually, this will be given to you important information, test number 1, but you have to understand this table. And here, I really should have changed this, the maximum number of electrons instead of this number of electrons. But subshell 2, you can only put 2 electrons. Subshell, when I say 2, subshell S, you can only put 2 electrons, P 6, well, hold on, 6, and D and F, D10, 10F. Now, you should know how to do the electron configuration. And that's a statement of how many electrons an atom has in each of its subshells. Now, subshell is always named by a number and a letter. A subshell is always named by a number and a letter, which is why I say hint, numbers and letters only. Now, let's take a look at one. Let's make it realistic, 3 points each. Yeah, test. If I had problem, I don't know, whatever number, 3 points each, draw the electron configuration for, oh, let's pick a fun one. Carbon. Well, how do you do this? Well, the first thing you have to know is how many electrons does carbon have? And you go to your friendly neighborhood periodic table and you look at carbon C. The atomic number is 6, so it has 6 electrons. So carbon has 6 electrons. Well, what's the first shell? And the answer is shell 1. You always put electrons in the lowest energy first and then go down toward the next lowest. So the first one is shell 1. How many subshells does shell 1 have? 1. We go here, and something I forgot to mention, and I'll do it now. This you have to know because I'm not. The lowest energy subshell would be S, but remember a subshell is a number and a letter. So that would be 1s. And the maximum number we can put in of electrons in 1s is 2. So I'm going to do that. So I have 1s, 2 electrons. Now, shell 1 has only one subshell, 1s, which you can put 2 electrons in. Well, we've done that, but we have 4 more to go to do all 6. So now we have to go to the next shell because we filled up shell 1 and it's subshell only 1, and that's 2. What's the first subshell in shell 2? 2s. And I can put 2 electrons in there. I will. So I now go 2s. Remember, a subshell is always a number and a letter. Any S subshell, how many electrons can I put in max? 2. Well, 2 plus 2 is 4. Uh-oh, I've got 2 more to go because I have to have 6. So what's the next thing I do? Well, shell 2 has 2 subshells. The first one is S. The second one is, or 2s. Second one is 2p. What's the maximum number of electrons I can put in any p subshell? 6. Well, I only have 2. So I go to 2p and I put in my 2. So I have 2 plus 2 plus 2 equals 6. I'm done. The answer is this. Now, do you have to write this and this down? No. But I'm showing you the thought process. By you being able to see it, helps you learn it better. And that's how you do the electron configuration. Can you keep a secret? Shh. This is my special gift to all of you. And I said this in the videos, but I'll say it again. For test number 1 and the final, you only have to know how to go up to magnesium for electron configuration. Remember, it's my special gift to you. Don't tell anybody about it. For test number 1, the final, for electron configuration, you only have to know how to do the elements up through 12 magnesium. When you get down here like nickel, copper, and all that, there are a whole lot of rules you got to learn. And I'd rather teach you more important things you would use in your daily life. Because after my class, I don't think somebody's going to come up to you, tap you on the shoulder on the street and say, can you show me how to do electron configuration of copper? I doubt that will ever happen. In fact, I'll bet it. All right. Now, the last thing I'd like to talk about are the valence electrons. And the valence electrons are the electrons, and you should know the valence electrons are the electrons in the outermost electrons in the element. They're the ones on the very outside of the electron cloud. And those are the most important because those are the electrons which you'll learn later in the semester are involved in chemical reactions. The fun stuff of chemistry, really. But anyways, how do you determine the valence electrons of an element? Simple. You go to your friendly neighborhood periodic table. If you look on top, I've written the numbers both originally in black, but so it's clear it's in red. And those are the number of valence electrons, and they're the same for all elements in a column. Hydrogen, lithium, sodium, potassium, right here, all have 1 valence electron. And I'm only doing the elements I asked you to learn the chemical symbols for, and those are the ones we use in our daily life. Magnesium, calcium 2, Come over here, carbon 4, number on top gives you the valence electrons, oxygen 6, chlorine, I've used chlorine a lot, 7, and argon, I used argon a lot in my graduate school studies during my PhD, and that has 8 valence electrons. So the number on top, and a number of years ago, all periodic tables just had the Roman numerals, like VI is 6, and I found out most of my students never were taught that, which is why I wrote the numeric numbers up there. So the number on top of a column tells you the number of valence electrons in that, of each element in that column. And you should know that. So if I ask you, oh, let's do one real quick. How many valence electrons does bromine have? Your turn. Time's up. Bromine, you should know, chemical symbol Br. Go to the top and you see the number 7. I see a number of people got it right. Yay. If we look, we're at the end of test number 1 review, and I now know why you see the handwritten. The last time I taught a 16-week semester of 1105, that's what I used. I copied that Blackboard instead of a newer one over. So I'll be posting later this evening the correct type test number 1 review file. And with that, I'm going to end. But for those of you who have questions, I'll stick around. I'll stop recording so you can ask some questions. I'll stick around. But if you're not, I'm going to say, as you've learned in Yiddish, "Gehen gesund," which means go in health. And I'll say goodbye now. I stole that from Granny and the Beverly Hillbillies. Goodbye now.